Okay, here's the last two questions on the review exam that deal with trig functions and transformations and modeling. So the first one says the volume of blood can be described by that function. And they say, what's the maximum volume of blood that the blood pushes out? We could use a combination of both the vertical translation and the amplitude to figure out how high it'll go. So this 105 means that it starts, instead of at 0, it starts at 105. And then this 35 means it goes 35 past that. So 105 plus 35 would be 140. So you could do that, or you can just graph it. So if you go into decimals here, here's my decimals, and I'm going to go, instead of V of t, I'm going to type y. I'm going to try and type y. Yep. Y equals 35 cos in brackets 5 pi over 3 x, and then close my bracket and go plus 105. Now I don't see any graph, it's because it's moved up 105. So if I shrink a little bit, there's my graph right there. Okay, I made it a little bit too big. Something like that. Anyway, to get the maximum, I can just tap on the top of it. So at 1.2 seconds, the volume of blood is 140. So the volume of blood at 1.2 seconds is equal to 140. So that would be the max that it pushes out. Then they say, at what time interval is this maximum reached? Well, it's reached there. Let's see when else it's reached. It's reached there, and there, and there, and there. So it looks like it's every 1.2 seconds. So at what interval time is this maximum reached? So the interval, I would say 1.2 seconds. That's when it reaches that first maximum right there. And then for how often it's released or reached, you can say every 1.2 seconds it comes back up to 140. So that's how I do that question. The next question involves a table that we're going to have to model. Oh, I had all the numbers typed in and it deleted them, darn. Okay, so I'll put them in again. 1, 2, oh, now it knows what I'm typing. 10, 11, 12. Go back up to 1. So minus 8, minus 7.4, 0.7, 3.1, 13.2, 16.8, 15.8, 10.6, 3.8, minus 3, minus 8.4. There we go. I can see some dots over to the right there. That looks like a nice periodic function. So now what I want to do is write the sine function. So down here, I tell decimals to do that. So y, and then a tilde, and you get this on your test. So then a sine, bracket b, bracket x minus c over b, 2 brackets to end, plus d. Oh, I forgot to put a 1 with the x. I always forget that. There we go. Okay. Oh, it's still not giving me any information there. Let me go up here. X1, Y1. Oh, I forgot to put a 1 with the y. That's why. There we go. Okay, so now the decimals has modeled that function for me, so I need to get some data from it. So the first thing I'm going to do is rewrite the function. So the function will be y is equal to a is 12.5, 12.5 sine, and then bracket. B is 0.55, call it, 0.55, bracket, x minus c is 2.28, 2.28 divided by c over b. B is 0.55 again. Bracket plus d is 4.03. So if they ask for the sine function, that is the function that seems to follow that pattern. Then they say, what's the temperature on October 15th? Well, October is the 10th month, and the 15th, I would probably call that 10.5. So here's 11, so 10.5 looks to be right close to there. Now, I could eyeball it up, but I can also go into decimals and type that. So if I go in here and I type x equals 10.5, oh, not 105, 0.5, you see that my line crosses there, and I can tap there to see what it is. So at 10.5, or October 15th, the temperature would be 0.349. So 0.349 degrees Celsius. And then, if they want to know the period of my function, the period is how long it takes to start a revolution, like maybe there, and it goes up, down, and then stops there. So I want to know how long that is. That's the period. And I could try and eyeball it up. It looks to be going like from 3 to 15, so like 12-ish, I don't know. But you can also do it this way. The period, and you have to memorize this formula. The period is 2 pi over b. So the period is 2 pi, and my b value is right there, 0.545, 0.545. So then on decimals, I can do that calculation, hopefully. There, 2 pi divide 0.545. So 11.5, and I was calling it 12, just eyeballing it, but that's a bit more accurate. 11.53, call it. There. Okay, so that's how you could do those questions.